Hi there, this is Ajit. Welcome to Step by Step Data Science tutorial. So today we are in part 8, Backpropagation algorithm. In part 7 we discussed about feed forward propagation, which is writing hypothesis of neural network. So today we will discuss about backpropagation algorithm, cost function, and we will implement all these things step by step from scratch in Jupyter Notebook. So let's start with backpropagation algorithm. So what is backpropagation algorithm? So backpropagation is used to minimize the cost function of neural network. Likewise, in logistic regression, we used gradient descent approach to minimize the cost function. Likewise, in neural network, in order to optimize the cost function of a neural network, we use backpropagation algorithm. So what is backpropagation and all the steps that are required for backpropagation? I will be explaining each steps line by line. So let's start with importing libraries. So this is my library. This is the same data set that we can found in end-to-end machine learning Coursera course. So this is my x and y variable. I have done this in my part 7 tutorial. So this is how we select top 100 samples. So this is how we visualize top 100 samples. So this is our random top 100 sample. So I have explained all these things in my last part 7 video tutorial. So this is the weights that we have in our data. So I have extracted my theta 1 and theta 2. So weights has two information that includes theta 1 and theta 2, and I have rolled that in and then params. This is rolled up of variable that includes the value of both theta 1 and theta 2. You can see I have concatenated that. So now I will be using 400 input layers. Why 400 is because my picture image is 20 by 20 pixel. So my 20 by 20, which is 400, which is equals to 400, that would be my input layer, and my hidden layer is 25 because the theta we have used in our this xp4 weights.mat. In this we can see the shape of theta 2. So it's 26. So my hidden layer will be 25, plus 1 will be my bias, which I will add later, and my output will be number of labels will be 10. This is my output. 10 denotes my MNIST handwritten data set, which is from 0 to 9. So this is my input layer, hidden layer, and number of layers. So this is the class that I have created. I will show you how I did that. So before jumping into backpropagation, let's discuss about cost function of neural network. So this is the cost function that this is the cost function that we implemented for logistic regression. So if we include I equals 1, we implement this equation, this will give us the cost function for neural network. So this is my cost function for neural network, where this k is my number of output levels, which is y. In our case, k will be from 0 to 9 because our MNIST handwritten dataset has image from 0 to 9. So we will be writing this equation, which gives us the cost function for neural network. So let's write the code for obtaining this equation. So my cost function will be, so I have done the transformation of my theta. So this theta has been transformed into theta 1 and theta 2 because here we can see I have rolled up my my theta1 and theta2 into nn underscore param. So that's why I need to unroll my theta. So I have already written the script that does the transformation. So I will call this theta1 and theta2 first. So dot so my m comma n will be x dot shape number of feature. This is my number of rows and n is number of feature. So I will initiate my j as 0 initially. So before doing this, I would like to explain about feed-forward propagation once again, because the h theta that we get from here, this h theta is how we this is my final output that we get from feed after implementing feed-forward a neural network. So before writing the cost function, we need to obtain h of theta, h theta of x, which is my feed-forward neural network. So let's implement feed forward neural network first, and then we will implement cost function. So my feed forward neural network will be something like this. So suppose I have three layers. This is my input layer, hidden layer, and my final output. So what I need to do is first I need to append one, and this will be my a1 of 1. So this will be my a1, and then I will calculate a1 times theta1, and then I will use sigmoid to calculate the activation function. So all these things I have explained in my lecture note 7. If you have any confusion, you can and see that lecture. So what I will do first is, so my feed forward propagation first will be my a1 will be, I have already written cost funds. I have already written how to calculate, how to append one. So this is my function which append one in my x variable. So why we need to append one is because this is my bias term, so I need to add bias. So I have explained that in my part 7 lecture. If you have any confusion, you can view that. So this is append one, which append one in x, and then my z2 is a1 times a1 matrix multiplication. This is dot multiplication of theta1 dot t. So theta1 is already given. So theta1 is this value that we have got. So we have our input weights is given. So this is my theta1 and theta2. So first we do dot multiplication, then my a2 will be sigmoid function I have already written in logistic regression model. So this is so you need to watch my logistic regression in part if you don't know how to write the sigmoid function. I have explained that in part 3 lecture, that is logistic regression from scratch. You can view my lecture notes. So this is the sigmoid, and I am using this Z2, and then again I need to open bias term here, open once, okay, save 2 comma 1, then a2. So this needs to be equals to 1 because also we are appending column wise. Again, my Z3 will be 8 times dot multiplication of Z2 dot transpose, and then again I need to take sigmoid of Z3. So sigmoid of Z3 is my hypothesis for cost function. So I will return A3 even A2 A1 because we need to use this value while calculating back propagation. So I am returning all these values. So this is this is my hypothesis for A3 is my final hypothesis. So that's how I get my final hypothesis, by implementing feed forward propagation. So that's what I will be using, reusing that in this is as of theta is what A3, this is A3 that I will be using while calculating my cost function. So to down this. Also I need to convert my y to one hot encoding because right now my y is ranging from 0 to 9. I need to convert this into 0 and 1 such that my y equals 0 0 0 0 2 3 4 5 6 7 8 9 4 4 9. It gets converted to something like this. So I need to convert into this value so that I can calculate my cost function. So that's why I have already written to transform y. This will be on the basis of number of labels. Okay, so my j will be 1 by m. So this part 1 by m, then 1 by m, 1 by m times minus y of times np of log of a3. So a3 is my hypothesis. Then I need to take sum. So this needs to be summed up in sum, because first one is sum is for adding a number of labels and this sum is for adding all my rows. So this sum is for 1 by k, and this sum is for all from 1 to m. This one is for 1 to k, this one is for 1 to m, and my k is number of labels. So here we go. So this is my cost function. Let's check if this is working fine or not. So here we go. We have received 0.28. Now what we will do is we will add regularization in our cost function. So for regularization, we will add, for logistic regularization was lambda by 2m, theta j equals 1 to m of theta j square. So in neural network, we need to add lambda by 2m, sigma j equals 1 to m, theta of ij square. So now let's add this term. Regularization is equals to lambda divided by 2 times m times. So this was theta, one is for theta 1 and another is sigma again j to 1 to m theta 2 square. So this is what we will be implementing, times double sum of theta 1. This is from 1, that's why we have included 1 here. This times this plus theta 2 square, theta 2, theta 2. This will again be sum. Again we need to do one more sum to add all labels of theta. Here even we need to do double sum. Okay, so now my j will be equals to j plus regularization lambda underscore. Now let's check. Let's keep my lambda as 1. It's written. Now here we go. So what we did now is we implemented cost function and regularization. So we implemented this equation plus regularization, this term. So now we are ready to start implementing backpropagation. So in order to implement backpropagation, so what is backpropagation is the feed-forward propagation computes hypothesis. So like in logistic regression, or we have g of z 1 by 1 plus e of minus z. Likewise for neural network, our hypothesis is feed-forward propagation. And likewise for logistic regression, my cost function is implementing gradient descent to get a minimum value of theta, implementing gradient descent to get minimum value of theta. Likewise for neural network, we need to implement backpropagation, And what backpropagation means is iterating through our output from final output and going backward is what backpropagation steps means. So in order to go backward, we need to first compute forward. So we need to have feed forward propagation first, so that we can get my final output. Then we apply backpropagation. So right now we have already written our script to calculate feed forward propagation, which is taking the multiplication and applying activation function, sigmoid activation function. So now the first step is already done. In second step, we calculate theta, we calculate delta. So what delta is? Delta is going backward. So for example, this is my 3 layer. So my third layer delta 3 is getting my output. So ak minus yk, ak of 3. So ak of 3 is my hypothesis. So this is how I got ak of 3 is my feed forward hypothesis that I have already derived. So my error will be delta of 3 will be feed forward minus my input yk. So I will be implementing. So first step is already being done, feed forward propagation. Second step is calculating the error delta. So why we are doing this is so that we can go backward and compute my initial theta. What would be my minimum error if I go back propagation, if I implement back propagation? What would be my minimum error, like we did for gradient descent in logistic regression to get minimum error? Likewise, in neural network we will implement back propagation to get minimum error, minimum value of theta. So how we get that is through implementing back propagation. So what are the steps for implementing back propagation? First one is, firstly we need to have feed forward propagation, which is hypothesis in terms of neural network, which I have already written code. And then we need to, and I have already written cost function. So cost function is already been written. Now I need to generate minimum value of theta, which is by implementing backpropagation. So second step is to calculate error. So these are the steps. If we follow these steps, then we get minimum value of theta by implementing backpropagation. So first step is to calculate error, which is delta of 3, which is my final. This is my hypothesis and this is my input value. This is the hypothesis that I got from feed forward, and this is my output y. So let's write the code to implement backpropagation. This will be my input value. So we know m comma n is my shape, x dot shape. In my theta 1 theta 2 is the transformation. So my feed forward hypothesis, I have already written this function. So this will give me a3. This is all I have written this value because these all values are used while calculating backpropagation. That's why I have written all these value. So my y will be transformed one hot encoded value. The function is already, I have written already. This is my function. So if this is not making sense to you, then please watch my part 7 lecture where I have discussed about one hot encoding in feed forward propagation. So my delta 3 will be, as I said, will be a3 minus y underscore new. So this will be my delta 3. What is delta 3? Delta 3 is computing error. Like for example, for linear regression, our error was h theta minus y whole square. So we were squaring the value for getting cost function j of theta, which is mean square error. Likewise, for backpropagation, we are firstly calculating delta 3, which is this. So this is my first step, which I have already written code. Delta 3, which is equals to a3. This is my output of feed forward propagation. H a3 is my final output. Okay. Now second step is to calculate delta 2. So this is my second step. So my delta 2 is theta 2 transpose delta 3. Delta 3 I have already calculated, and g transpose g derivative of z2. So what is g derivative of z is g of z 1 minus g of z. What is g of z? G of z is 1 by 1 plus e to the power minus z. So how did we came up with this value? I will explain you that now. So that is what we call sigmoid gradient. So sigmoid gradient z derivative of gz is gz times 1 minus gz. So this is what we need to prove. Okay, so my gz is, we know that 1 by 1 plus e to the power minus z. This is my logistic regression sigmoid function. Okay, so if we take derivative of gz with respect to dz, this will be 1 plus e to the power minus z whole minus 1 by derivative of 1 plus e to the power minus z times d of 1 plus e to the power minus z. So this is applying chain rule, 1 plus e to the power minus z. Now minus 1 plus e to the power minus z whole minus 2. So we know that derivative of x to the power n divided by the power x is n x to the power n minus 1. So this is my n x to the power n minus 1, and derivative of, we know that derivative of constant with respect to anything is 0, and derivative of e to the power minus z by e to the power z is minus e to the power minus z. So this is all we need to know. This will be my minus e to the power minus z. Okay, so now it will be minus will be plus e to the power minus z by 1 plus e to the power minus z whole square. Then this will be 1 by 1 plus e to the power minus z times 1 times e to the power minus z by 1 plus e to the power minus z. This will be my g of z. Now let's multiply, let's add 1 and minus 1 divided by 1 plus e to the power minus z. This will be g of z times 1 minus 1 by 1 plus to the power minus z. So if we separate it out and then we divide it by z, then this is what we get. So let me simplify this for you. 1 by 1 plus e to the power minus z. So 1 plus e to the power minus z, this can be written as this minus 1 by 1 plus e to the power minus z. So this will be cancel out. This will be remaining. So this will be the z times 1 minus the power minus z. So derivative of g to the power z with respect to dz is this. Okay, so this is what we called sigmoid gradient. So let's write this equation first, because we need to, in next step, in second step, we need to compute derivative of sigmoid function. So let's write the sigmoid gradient first. So my sigmoid gradient will be, so z1 will be, so sigmoid function I have already written, so this dot sigmoid, so dot z 1 minus, this is my z2, say, and g is z1 times z2, and then we return g. So this is how we compute g dash z. So right now we have written a function to compute g dash of z, which is equals to g of z times 1 minus g of z. Okay, so in next second step I will be doing transpose of theta of z times delta of 3, which I have already calculated, and g dash of z, which I have already written my function. Okay, so this will be delta 2, which will be delta 3 matrix multiplication of theta 2. This will be from 1 because we don't consider delta 0. Delta 0 is our input variable. That's why we start from 1. This will be this times the gradient descent sigmoid gradient equation, which I have already written, z2. Okay, so in second step we have implemented, this is my delta 2 times delta 3 times theta 2 transpose theta 2. So we can check whether we need to transpose or not. It depends on multiplication matrix which we are using, and then times gradient descent of z2. I have already written that, z2. Okay, then my third step is to multiply this is my derivative of theta. So if we take theta, gradient of theta, that is how we denote this. This is my theta gradient. So let's initialize my theta gradient first. So what is theta gradient? I will explain you in a bit of moment. So let's initialize theta gradient. See, this is equals to this plus delta 3 dot product of delta 3 times delta transpose times a2. So this is my a, this is what I initiated. This is my delta of L plus 1. So if my theta is 2, this will be 3 times A2. This is A and transpose, which I have already done. So likewise for theta 1, and this will be 1, and this will be 2, and this will be 1. So it follows this convention. Here L is, if L is 2, then this is my theta grade 2, theta grade 2 plus L plus 1, delta of 3 times A of L, which is 2, A2. That's what we did. So we completed our third step, and then finally we divide our theta 1 upgrade with 1 by m times theta 1 upgrade. So this is how we implement backpropagation by following these 4 steps. Now one step is again missing, to add regularization term. So in order to add regularization, we again add, this will be my theta of L plus lambda by m times theta 1. This is again from first position. So this is the one step remaining that we need to add. This is for regularization. So now my theta 1, this needs to be started from one position. So plus theta length divided by m times theta 1. This is again from first position. Okay, so likewise for 2, 22, 2, that 2, okay. And then we finally add it into one, roll up into one. We feel written that. So this is the steps that we need to implement. If we include these all steps, we have implemented backpropagation. So we have implemented these 5 steps. So first step was to calculate delta 3, which I have already done. This is my first step. This is then delta 2, then delta gradient, and then this is my regularization term. So this is my first step, step 1, and this is my second step. First step, calculate delta 3, okay. Then second step is calculate delta 2 with sigmoid gradient. And in step 3, calculate theta 2 underscore grad and theta 3 underscore grad. And then fourth step is to divide by m, and fifth step is add regularization. Okay, so by implementing these 5 steps, we have implemented backpropagation. Okay, so let's check if this is working fine or not. So I have also written those steps over here. So this is the steps that I have taken from Andrew 9 Coursera course. So Andrew 9 machine learning course, you can find these steps. So this is the steps that I have replicated. So likewise for sigmoid function, this is the value, and the proof I have already shown you the proof for that. So let's check if all things working fine or not. So my sigmoid gradient, let's check first if that is working fine or not. If I not array of -1 and 0. Let's check if it is working fine or not. Let's restart. So yeah, for 0 we are getting 0.25. So this looks fine. Now let's check my gradient descent if that is working fine or not. So this is my theta 1 and theta 2. Okay. So I'm able to run backpropagation, and I'm not getting any error. So now we need to confirm whether our implementation is correct or not. For that we do gradient check. So this is the function that we have already written. So gradient check is needed so that we can confirm whether the implementation that we did for backpropagation is correct or not. For that we write gradient check. And another thing we do is we even initialize the so this is the again one thing we do is we do random initialization, which is symmetry break. So we need to do random initialization because in logistic regression, and we did what we for theta we initiated it to be 0. So in neural network we cannot initiate it with 0, because so if my theta is 0, then this is my x, and this times this will be 0. So my a1 a2 1, so a2 1 will again be equals to a2 2. Likewise, if we compute delta 3, delta 1 of 3, and delta 2, so again delta 3 of 1 will again becomes equals to delta 2 of 1. Derivative of theta 1, even that becomes equals to theta 2. So this does not contribute significant amount of we don't see any good output if we don't implement, if we initiate it by simply by 0. We don't see any exciting value for testing our neural network. So for that we use random initialization, and which breaks the symmetry. Break symmetry means it will populate some value for our theta, and it will break the equalization for calculating a1 or d1. So the formula for using random initialization is we calculate w, and w will be our np random value for theta and theta 1, suppose, and theta 2 plus 1 times 2 times we give epsilon minus epsilon. We set epsilon, so we set epsilon to be something equals to 0.12. so if we implement, if we write this equation, we get the initial value of theta 1 and theta 2 will be a random value ranging from will be our random value with epsilon 0.12. So that's what we do for calculating random initialization. So let's write this code to calculate random initialization. Let's write it down over here. Initialize with back itself dot in and out epsilon integer 0.1 0.12 we have taken. So let's initialize first. Let's in of out comma 1 plus of times 2 times minus let's done this. Mm, okay, so this is how let's restart. Now we need to call our gradient over here. So this is the backpropagation that we have implemented. We need to call that in our cost function. Mm, So here we go. So this is the gradient descent check for verifying whether my backpropagation logic is correct or not. And we see value close to each other, like two values are quite close to each other, and the implementation is correct, and relative difference is very less. So we have implemented backpropagation and verified it with gradient descent check. So gradient descent check works fine. Okay, so we can see that values are matching and it looks good. It's less than. So now what we will be doing is we will be using optimizer, so that we can optimize the get minimal value of our theta. So for that we use scipy minimizer library. So this is the cost function that I have already written. So after passing through this cost function, we get optimal value of theta, and this is my final output. So the prediction is we have 95.98% accuracy in our module. So this is how we implement backpropagation, and I have also included these steps over here. And this is how we implement cost function backpropagation from scratch. If you like the video, please like my channel. Hope to see you soon. Goodbye. Thank you.